to talk to you about three guys in a box. Three radically different guys. Where I'm talking about sum of forces on the y, and the thing that I'm seeing a lot of you do is assume that normal force equals mass gravity. It doesn't always. We start off with problems where it generally does. This is probably a fairly important conversation. So the compelling argument for doing sum of forces. So in that first case where we have a person about as tall as the box and the force that they are delivering to that box is directly horizontal, so I'll give them a little green line. The force of friction back, I'm going to draw that right through them, is going to be directly horizontal. If we do a sum of forces for that on the y-axis, we have Fg, oops, gosh, Moser, Fn, Fg, it's equal to 0, Fn minus Fg. So normal force is going to equal mass gravity. In the case of that second person, when we do the sum of forces, when we do sum of forces here, sum of forces on the y is still equal to 0. The box still isn't lifting into the air spontaneously, but we now have an applied force from that person that's partially down. So their force is actually somewhere over here, which means there's a y component to their force, which means that we now have normal force minus force of gravity minus the force applied on the y-axis. So our normal force is actually going to be greater than gravity. The floor is providing more push upwards because it's countering the additional force that that person's putting down on it. When we have our little tiny person here who's actually applying some of their force upward, sum of forces is still 0, but now we have normal force, plus force applied on the y minus force of gravity, because they're actually starting to push that box up. We'll see this on Monday when we start dragging around boxes of our favorite things on ropes, and you'll be applying force upward. So you'll actually sort of be helping out the floor. The amount of friction in each of these cases changes. The coefficient of static friction doesn't change. That never changes. That's a surface-surface pair thing, because the normal force changes. When the normal force changes, the amount of the friction changes, and that's what we're going to explore next week in our little mini lab. That's why you need to start each one of these with sum of forces, because you have to prove that normal force is equal to whatever it's equal to, which is not always mass gravity. So this is all pushing examples. We can just as easily do a box with a string on it and force being exerted at an upward angle. There, that force applied on the y is going to make normal force less than the force of gravity, because that's helping the floor out. So please, please, please make sure you're starting with a sum of forces in a picture, because it really matters. They're going to get progressively more complicated as you go through the 4C stuff. That's it.